Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0341 indicates an issue with the CMP Camshaft Position sensor A and CKP Crankshaft Position sensor showing an incorrect phase reading. These sensors play crucial roles in the vehicle's engine management system by ensuring proper timing for ignition and fuel injection, which are critical for engine performance. The CMP sensor monitors the position of the camshaft, while the CKP sensor tracks the crankshaft's position. Both sensors must work in harmony to allow the engine control module, ECM, to adjust timing effectively, ensuring efficient engine operation. When a discrepancy occurs, such as that indicated by DTC P0341, it can lead to poor engine performance, increased emissions, or difficulty in starting the vehicle. For the Honda CRV, these components are typically located near the engine assembly, with the CMP sensor attached to the cylinder head and the CKP sensor located on the crankshaft or near the engine block. Understanding the correct function and location of these sensors is vital for effective troubleshooting. The DTC P0341 indicates that there is an inconsistency in the phase detected between the camshaft position sensor A and the crankshaft position sensor. The CMP sensor is directly responsible for monitoring the rotational position of the camshaft relative to the crankshaft, while the CKP sensor keeps track of the crankshaft's rotation. Proper communication and alignment between these two sensors are essential, as any incorrect phase readings can disrupt engine timing, resulting in performance issues. Both sensors are critical to the vehicle's PGM-FI, Programmed Fuel Injection System, which manages fuel delivery and ignition timing. When the PGM-FI detects any discrepancies, it sets the P0341 code, alerts the driver or technician that a malfunction may exist, and initiates a series of diagnostic steps to identify the problem. Effective diagnostic procedures are necessary to ensure that the root cause of the phase discrepancy is identified and rectified, preserving engine performance. There are several reasons that could lead to the occurrence of DTC P0341. One possible cause is poor electrical connections between the CMP or CKP sensors and the engine control module, ECM. These can result from corrosion, wear, or loose terminals which disrupt the signals being transmitted. Another potential issue could be a faulty VTC, variable timing control solenoid, which may fail to operate correctly, affecting the timing adjustments needed for optimal engine performance. Additionally, an incorrect camshaft timing can be another source of the problem. If the camshaft isn't aligned correctly with the crankshaft, it can lead to irregular phase readings. Lastly, a damaged or stretched cam chain could impact the synchronization between the camshaft and crankshaft. Understanding these possible causes is crucial to aid technicians in pinpointing the source of the problem confidently. The symptoms associated with DTC P0341 exemplify issues stemming from the incorrect phase detection between the camshaft and crankshaft sensors. A common symptom is a rough engine idle, which may indicate that the engine is struggling to maintain a steady rhythm due to timing errors. Drivers might also experience poor acceleration, as the engine cannot perform optimally without the correct timing for fuel injection and ignition. Additionally, engine stalling may occur when the car is running, exacerbated by the potential disconnection between the cam and crank sensors. These symptoms can hinder driving safety and performance, while highlighting the importance of immediate attention to any warning lights or performance issues. Identifying these symptoms early can lead to quicker solutions and prevent further engine damage. The first step in troubleshooting DTC P0341 entails verifying the problem using the HDS Honda Diagnostics System. You begin by turning the vehicle to the on mode, which powers the electronic systems without starting the engine. This is critical for accessing the diagnostic codes stored in the PGM-FI system. Next, you clear the DTC using the HDS to reset the error status. Once cleared, the vehicle should be turned off, allowing the engine to cool to below 104 degrees Fahrenheit, 40 degrees Celsius, for safety and effectiveness in testing. After the cooldown, start the engine and let it idle without load, either in the park or neutral position. Finally, check for any confirmed or pending DTCs again using the HDS to determine if the error persists, marking a cornerstone process in the verification stage necessary for accurate diagnostics. In the second step of the troubleshooting process for DTC P0341, you must check the VTC, Variable Timing Control System. This is done by selecting the VTC test option in the HDS under the inspection menu. Performing this check is essential as it helps determine if the VTC mechanism, which controls camshaft timing adjustments, is functioning properly. If the VTC test yields an OK result, it confirms that the VTC system is likely not at fault, and you can proceed to further diagnostics. Conversely, if the test indicates a failure, that directs you to further investigate the VTC components, which might include the VTC oil control solenoid valve. Proper operation of the VTC system is crucial in regulating engine timing, thus being a key component in troubleshooting DTC P0341. Step 3 involves performing a test drive at a steady speed of between 19 to 38 miles per hour, 30 to 60 kilometers per hour, for approximately 10 minutes. This driving period allows the engine and VTC to reach normal operational conditions, enabling accurate readings of the VTC status. After the test drive, you will check the parameter values related to the VTC using the HDS. You're specifically looking for the VTC status to confirm whether it shows as on, indicating that the system operates within expected thresholds. It's crucial to compare the current conditions against the predetermined threshold values. If they match, it suggests the system is functioning properly. However, if there is a discrepancy, a second test drive might be necessary to gather further data and confirm consistency in the VTC status. This step serves as a pivotal point to either validate system functionality or recognize subsequent areas for diagnostics. In Step 4, monitoring the onboard diagnostics (OBD) status for DTC P0341 in the DTC menu with the HDS becomes crucial. You must ascertain whether DTC P0011 for VTC system malfunction has been indicated during this check. If the HDS shows a failed status for P0341, this directs you back to investigate further issues possibly related to the VTC system, suggesting that the previous checks revealed a real malfunction. On the other hand, if the system status indicates past or highlights an intermittent failure with the current DTC being absent, it implies that, at that moment, the system appears to be functioning correctly. Tracking these findings is fundamental for substantiating whether the problem is only transient or a recurring concern needing more attention. Taking note of any onboard snapshot data can help recreate the failure scenarios in future tests. Step 5 focuses on checking the operation of the VTC, Variable Timing Control Oil Control Solenoid Valve. This component is crucial because it regulates oil flow to the VTC system, which adjusts the camshaft timing based on engine conditions. Begin by testing the solenoid valve. This can involve checking electrical connections, voltage, activation, and resistance to ensure it responds as expected. If the VTC oil control valve is deemed functional through your testing, you would then proceed to the next troubleshooting step. Conversely, If the valve fails this test, it requires immediate replacement. A malfunctioning VTC oil control solenoid can lead to timing issues. Hence, it's integral to confirm its integrity during this diagnostic process, largely affecting the engine's overall performance and operation. The sixth step of troubleshooting involves a meticulous check of the camshaft timing. This action is important as the camshaft timing must be in precise alignment with the crankshaft for optimal engine operation. If the camshaft has drifted out of alignment, it may lead to incorrect phase readings displayed by the CMP and CKP sensors, subsequently setting the DTC P0341. After inspecting the timing marks on the camshaft gear and comparing them to specifications, if everything aligns correctly, this indicates that the timing is fine, allowing you to move forward to the next diagnostic steps. Should you find that the timing is off, resetting the camshaft timing becomes necessary to ensure that it correlates accurately with crankshaft positioning. Properly synchronized cam timing is critical for effective engine performance and emission standards. In Step 7, the inspection of the cam chain is vital. The cam chain connects the crankshaft and camshaft, synchronizing their movements, which is crucial for correct engine timing. During your inspection, you're checking for physical damage, such as excessive wear, cracks, or stretches that could impede the cam chain's functionality. If the cam chain is found to be damaged or significantly stretched, it becomes necessary to replace both the cam chain and the auto tensioner. A compromised cam chain can lead to synchronization issues, causing an incorrect phase to be detected by the CMP and CKP sensors. Regular inspection of the cam chain also plays a crucial role in preventive maintenance, helping to ensure longevity and reliability of the engine's timing systems. Step 8 requires inspecting the VTC actuator, as it plays a vital role in adjusting the camshaft position based on the oil flow controlled by the VTC solenoid. A malfunctioning actuator may fail to respond appropriately to the solenoid's commands, leading to issues in timing that can trigger DTC P0341. During the inspection, evaluate the actuator for any visible signs of wear, damage, or malfunction, and ensure that it operates smoothly when prompted. If the actuator performs its functions as intended, you can proceed to the following diagnostic steps. However, if it fails this inspection, it's imperative to replace the VTC actuator proactively to maintain optimal engine performance. The actuator's proper operation ensures the timing can be adjusted efficiently according to engine load and speed. Step 9 consists of performing a complete check on the PGMFI, Programmed Fuel Injection System, starting by turning the vehicle to the on mode and resetting the PCM, Powertrain Control Module, via HDS. This reset clears any residual fault codes stored by the module. Following the reset, you must execute the CKP, Crankshaft Position, pattern clear procedure, ensuring that the PCM properly calibrates the crankshaft's position. After the crank pattern clearance, conducting the PCM idle learn procedure becomes necessary to calibrate idle conditions accurately. This ensures the PCM adapts accordingly for any changes made during diagnostics or repairs. You also need to perform the CKP pattern learn procedure, ensuring that the PCM understands the specific timing and position of the crankshaft. Upon completion of these procedures, a test drive at a steady speed must occur yet again, monitoring for any pending or confirmed DTCs. After completing all previous steps and repairs, performing the final verification is crucial. This involves checking again for any instances of DTC P0341 using the HDS. If DTC P0341 is indicated during this stage, it requires you to check for poor connections or loose terminals at both the VTC oil control solenoid valve and the PCM, as these connections may cause intermittent errors, leading to the detected phase issue. Tightening or replacing faulty connections should remediate any lingering faults. On the other hand, if DTC P0341 is not detected at this time, it suggests the issue has been resolved successfully, allowing the system to operate normally without illumination of the warning indicators. This verification step is necessary to ensure that no further action or repairs are needed, and that the vehicle is back to optimal working condition. Preventive maintenance is essential to avoid the recurrence of issues like DTC P0341 down the line. Regular inspections of the camshaft and crankshaft sensors, as well as the associated wiring and connectors, help ensure optimal engine performance. Technicians should routinely examine the integrity of all electrical connections to avoid corrosion and damage, which could lead to future errors. Regular oil changes also serve to maintain VTC performance, because clean oil is crucial for the effective function of oil-dependent components like the VTC solenoid and actuator. Being proactive about maintenance can help extend the lifespan of these components, reducing the likelihood of errors and costly repairs in the future. By keeping a vigilant watch over these systems, vehicle owners can ensure higher efficiency and reliability from their Honda CRV. In conclusion, addressing DTC P0341 involves a systematic approach to diagnosing and resolving issues related to the CMP and CKP sensors. The thorough troubleshooting steps taken ensure that potential sources of malfunction are meticulously examined, including electrical connections, the VTC system, camshaft timing, and associated components. Proper diagnostics are crucial, as they not only highlight specific issues, but also guide technicians to effective solutions, ensuring optimal engine performance. Understanding the underlying mechanics of how these sensors interact is essential for accurate repairs and preventive measures. By adhering to a structured troubleshooting procedure and regular maintenance schedules, vehicle owners can help mitigate future problems while ensuring their Honda CRV remains a reliable mode of transport. Please like and subscribe to the channel. See you next time.